So in a non-mathy way, this limit is going to be -1/4 because look at the powers on top of the variable. The power of 1, this is the square root of a second power. That's going to cancel out, make a power of 1 over a power of 1. Okay, and it's going to be negative because the numerator is going to be negative as the denominator is going to be positive because you're squaring any number you plug in here. The powers match. The power of 1, we have a negative in the top and a positive in the bottom. That's why it's a negative. And it's a 1/4 because if the powers match, the limit is t goes to infinity or negative infinity, it levels off as a ratio of the coefficients. The square root of 16 is 4, and, well, actually we don't have a square root, but this is a 1 in the numerator. So that's why it's -1/4. Now, that's not a super mathy way of doing it. I guess it is because we're talking about end behavior like we have talked about before, but let's do it in a more algebraic way. You can, we want to rewrite this so that we don't have a t inside the square root. So we can at least look at the numerator and look at the denominator and have equal powers or something similar. So let's factor out that t squared in the denominator. And then you're going to have 16 plus 9 over t squared. And then what else can we do? So you're taking the square root of a number that's being squared. So you got to use an absolute value. So this is the absolute value of t in the denominator. And since this is a limit as t goes to infinity, this term's great over here because if you think about infinity being substituted for t, if 9 divided by an incredibly huge number, 9 divided by a number we never actually reach, so this is pinching off to 0. We like that when we're evaluating limits. Here we got to do something with this infinity. This is the limit as t goes to negative infinity. One thing we can say is that since this is the absolute value of t, and again, here just real quick, we got the absolute value of t because when you factor out the square root of t squared and square root of 16 plus 9 over t squared, you're square rooting a square number. This is always going to be positive here. But one thing we can say is that we can drop the absolute value sign and just say this whole limit is negative because it's the limit as t approaches negative infinity. Right? Because this is always going to be positive. But as t approaches negative infinity, this is always going to be negative. This is always going to have a positive result. So we know the numerator is always positive, and we know we know the denominator is always positive. We know the numerator is always negative. So we can stick a negative sign in front of this limit. And now we can simplify it, and then we've taken care of the absolute value part of our limit. We know that this whole thing, that the sign of the number isn't going to matter as long as we say it's negative in the end. So that's why we can drop the absolute value. And we have t over t. So those can cancel out. So we have a -1 up top, and a square root of 16 plus 9 over t squared on bottom. And then we like this part. It's the limit as t approaches negative infinity for 9 over t squared. We can use our properties of limits to just evaluate the limit of the inside of the square root. This is going towards 0. So we have, that shouldn't be an equal sign there. We have that this limit is equal to -1 over the square root of 16, which is what we got when we did it with kind of end behavior approach at the beginning, -1/4.